In the intensive care unit, every single second counts. But what if you could see a crisis coming? Not just seconds away, but maybe hours in advance. Well, today we're jumping into an amazing explainer on how AI is being trained to do just that, to predict life-or-death outcomes and spot danger before it's too late. And that really gets to the heart of the problem, doesn't it? In an ICU, doctors are just flooded with data. You've got vitals, lab results, charts. It's a constant, overwhelming stream of information. So the huge question is, how do you possibly find the signal in all that noise? How do you spot that one patient who's about to take a turn for the worse? To get a sense of the scale here, the researchers looked at this huge data set of over 88,000 critically ill patients who also had hypertension. And this number, 3.9%, that's the percentage of those patients who didn't make it out of the hospital. Now, it might seem like a small number, but behind that percentage are thousands and thousands of real people. Right. So for patients with high blood pressure who are already in the ICU, the stakes are just incredibly high. Their condition can go downhill fast. This makes spotting the risk early on absolutely critical if doctors are going to have a chance to step in and save a life. Just try to imagine it. Hundreds, maybe thousands of data points are being generated for every single patient. And somewhere, hidden inside all that data, are these subtle clues, these faint patterns that could signal a crisis is coming. But finding them, it's like trying to find a needle in a haystack. And that's exactly where machine learning comes into the picture as a potential game changer. So how in the world do you teach a computer to be a medical detective? Well, the researchers started with a massive public data set called Mimic-4. It's packed with detailed, real-world information from ICU patients, and that's where they began the process of training their AI models. Now, this wasn't just about, dumping a bunch of data into a machine and hoping for the best. No, it was this super meticulous four-step process. First, they pulled all the relevant patient records. Then, they had to clean all that data, getting rid of errors, filling in the gaps. Next came something called feature engineering, which is just a fancy way of saying they created new, useful data points from the ones they already had. And finally, they picked out the most important clues to feed into their AI. Okay, this is where it gets really fun. The researchers didn't just pick one AI model and call it a day. Nope. They set up a competition, a kind of AI battle royale, between 6 different models to see which one would be the absolute best at predicting which patients were most at risk. And here are the contenders. On one side, you've got 4 classic machine learning models. Think of these as the seasoned veterans. And on the other side, we have 2 deep learning models, which are kind of inspired by the human brain and are really good at finding complex patterns all on their own. The big question was, which one was going to come out on top? So after all the training, all the testing, a clear winner emerged. It was the gradient boosting machine, or GBM for short. And get this, it wasn't just the most accurate. It was also the most stable and reliable when it was shown brand new data it had never seen before. And that right there is exactly what you need in a real-world hospital. You can really see its edge right here. At nearly 90% accuracy, the GBM just pulled ahead of the competition. Now, a couple of percentage points might not sound like a lot, but believe me, in an ICU, that small difference can mean everything. Okay, so we've got our winner. It's super accurate. But that brings up another huge question. A model like GBM is really powerful, but it's often called a black box. We know what it predicts, but we don't really know why. And to trust it with patients' lives, we have to be able to look inside. So to crack open that black box, the team used this really clever tool called SHAP. The easiest way to think about SHAP is like a translator for the AI. It takes a prediction and tells you in plain English exactly which pieces of patient data push the model to make that call. And what they found inside was just fascinating. The AI wasn't looking at some weird, obscure data that nobody's ever heard of. No, it was zeroing in on the exact same clues that experienced doctors know are critical. Things like the Glasgow Coma Scale, which measures consciousness, or a patient's kidney function. It's like the AI had taught itself to think like a doctor, but with the power to see patterns across massive amounts of data almost instantly. But wait, it gets even better. The researchers then tried something really interesting. They built a stripped-down version of the model, using only the top 30 most important clues instead of all 400 plus. And incredibly, it performed almost exactly the same. This is a huge deal because a simpler, more efficient model is way easier to actually use in a chaotic, fast-paced ICU. So we have a model that's accurate and efficient.
But that's only part of the story. For any AI tool to be truly useful in medicine, it absolutely has to be fair. It needs to work just as well for every single patient, no matter who they are. And that brings us to the really critical issue of bias.
To check for fairness, the researchers used a couple of key tests. The first one is called demographic parity difference, or DPD. Basically, it asks a simple question. Is the model flagging risk at about the same rate for different groups? For instance, is it predicting mortality for men at a much higher rate than for women? If so, that could be a red flag for bias. The second test is called equalized odds difference, or EOD. This one goes a step deeper. It looks at the model's error rates. Is the AI more likely to miss a high-risk patient if they're a woman versus a man? Or is it more likely to raise a false alarm for one group over another? Ideally, you want those error rates to be the same for everybody. And this is where it all comes together in this really cool, surprising way. Remember that simpler model, the one that only used 30 clues? Well, it turns out it wasn't just more efficient, it was also fairer. It showed less bias on both of those key fairness tests. This is a massive discovery, because it suggests that by being really thoughtful about the data we feed our AI, we can actually build them to be more ethical from the ground up. So what does this all mean for the future of the ICU? It's really important to understand that the goal here is not to replace a doctor's expertise and intuition, not at all. It's about creating an intelligent co-pilot, a tool that empowers clinicians and helps them see things they might otherwise miss in that flood of data. And you don't have to take my word for it. The researchers themselves summed it up perfectly. Their goal is to build tools that are scalable, meaning they can be used everywhere, equitable, meaning they're fair for everyone, and actionable, giving doctors insights they can actually use to help save lives. Ultimately, this study is a powerful proof of concept. It's a blueprint showing that we can build AI tools that are not only incredibly accurate, but also understandable and fair. And it leaves us with this really exciting question. Now that we have these new digital detectives, what's the next life or death puzzle they're going to help us solve?